Alright, so, hey guys, how you doing? We're going to be starting chapter 10 here, and this is square root functions. You all know what a square root is, hopefully. It's also called a radical at times. But one thing to know is that there are certain perfect squares. You can take a square root of pretty much any number, but we're really going to focus on perfect squares today. A bunch of them are listed on the left here, as you can see, all the way from the square root of 0 to the square root of 289, which would be 17. And this would be 0, obviously. All the numbers in between. A square root function, something like f of x equals radical x. That's just function notation. You might see here, this says f of x, this says y. They're interchangeable. We're going to plug some numbers in for x. It's a table. You will eventually learn shortcuts, just like you learn shortcuts for everything. But if you ever forget a shortcut, your backup plan is always just plug in numbers, see what happens. And that's what we're going to do here. So the first number I'm going to plug in is 0. And very easily, when I plug in 0, I get square root of 0, which is 0. 0, 0. I'm going to now plug in 1, very normal, 0, 1. I get square root of 1. I know the square root of 1 equals 1. I get the point 1, 1. Now, if I pick 2, now I wouldn't normally pick 2, but we're going to try to kind of not make a mistake, but mess ourselves up intentionally here. If I pick 2, I get the square root of 2. Now, the square root of 2 is an irrational number. It's some crazy, ridiculous decimal. You could look it in the calculator. It's very difficult to graph by hand. I don't know the square root of 2, and if I don't know the square root of 2, there's a good chance you don't know it off the top of your head either. So our goal now is to plug in a number for x that I do know the square root of. And that's why all these perfect squares are here. Square root of 0 I know. Square root of 1 I know. So the next number I can plug in. Like I said, if you try to plug in 3, you're screwed, because I don't know the square root of 3. So I plug in 4. So like I said, I didn't know the square root of 2. 4, and I'm like, oh, the square root of 4. I know the square root of 4. The square root of 4 is 2, and I get that point. And I could find a few more. Like I said, 5. I don't know the square root of 5. 6, I don't know the square root of 6. 7, what the hell is that? The next perfect square I have is 9. So I would plug in a 9. When I plug 9 in for x, I get the square root of 9. And the square root of 9 equals 3, and that's what I have. That's a bunch of points. That's 5 points. We're going to graph them now. 4, 2, 1, 2, 3, 4, up 2. 9, 3, 9, up 3. And those are the points I have. They kind of make this curve. If you look, you kind of see this little arch. And what it's going to look like is this. Now, the main thing to realize is that there is only one directional arrow going. It's going to be going to the right, and it's going up to the right. I could have kept going here. 16, 25, 36. And like I said, you can plug in random numbers too. I could find out what the square root of 20 is. I just might not be able to graph it because it's some ridiculous decimal. The reason there's no arrow going here, though, because below 0 is the negative numbers. Notice 0 is the smallest perfect square I can get. I cannot take the square root of negative. So this graph, some people call this I think of this as a starting point. Some people consider it an end point. It's interchangeable. If you look at if you look online, some people call it a start. Some people call it an end. I'm a fan of calling it the start point. This is where the graph starts. It starts at 0, 0, then it just goes up to the right forever and ever. This brings us to our domain and range. If you remember, domain is just our x value. So it's asking you, hey, what's going on with your x values? Well, x, if you look, you can literally look at your graph. X's are just getting bigger. 0, 1, 2, 4, 9. They are growing. If you look at your graph, you see it too. It just keeps going to the right, getting bigger, 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 bigger. So x is growing, so x is getting greater than, and equal to, it is equal to 0. And if you look at your table, it starts at 0, and the numbers just keep getting bigger. If you look at your graph, it starts at 0, and the numbers just keep getting bigger, bigger, bigger. Range, if you remember, is our y value. What's going on with our y's? If you look at the graph, you can look, oh, the graph starts right here. Your y's are up, down, and it just goes up, 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 up. What's it start at? Well, it starts at 0 and it goes up, so greater than or equal to 0. You can also look at your table. Your table gives you the same information as your graph. 0, 1, 2, 3. You could see the numbers growing and getting bigger. Like I said, you can look at your graph, you can look at your table. All that information is there for you. It's a matter of which one do you like to get it from. Okay? That's our first graph. Now for our next graph, you will see it's square root of x plus 3. And this one has a y equals. Same crap, doesn't matter, remember. Now the square root of x plus 3 causes a slightly different issue. Because now when I plug in a number, something like 0, so let's show you what happens if I plug in 0. If I plug in 0, 0 plus 3 is 3, and I get square root of 3. I don't know the square root of 3 off the top of my head. I would need a calculator, and once again, once I get it, it's going to be some ridiculous decimal. Decimals like that are very difficult to graph. You can graph halves, thirds, quarters. Irrational numbers are a little tougher. So I don't know what this is. So I kind of am just going to ignore that. Your goal is, once again, right here. Your perfect squares. You need to get this number, square root of 0. That's the perfect square, I know. That's where this graph is going to start at. If I can make this, I'm good. So you have to figure out what number goes in here to give you 0. Now technically, you can solve a little equation for that. I think a lot of you are smart enough to figure out on your own that blank plus 3 to get you 0 would be negative 3. When I plug a negative 3 in there, that becomes negative 3 plus 3, which is 0. There's my square root of 0, which is 0. There's my first point, negative 3, 1, 2, 3, 0. Now I want to plug in another number. Like I said, you have to kind of think ahead of here. You can just plug in numbers randomly, but you're going to get a lot of crap that way. You're going to get a lot of irrational numbers that don't make sense. The next number I kind of want to shoot for is this radical 1. I know the square root of 1. Square root of 1 is 1. How can I get this to be square root of 1? What number would x have to be to make this 1? Now once again, you can solve a little equation for that. You could do x plus 3 equals 1, do the math. But a lot of you are quick enough to kind of realize, oh, negative 2. If I plug a negative 2 in here, negative 2 plus 3 is 1. That gives me the square root of 1. The square root of 1 is 1. I now have the point, negative 2, 1. Like I said, you just keep going down the line. How do you get 4? What number would I plug in here to get 4? Like I said, I can solve an equation, x plus 3 equals 4 minus 3 minus 3, and go, oh, I need to plug in 1. That's a lot of work, I feel, for something that's going to be kind of obvious. And like I said, if you were in 5th grade, hell, if you were in like 3rd grade, you probably would realize if I gave you blank plus 3 equals 4, most of you would know to shout out 1. And if you plug in 1, you get the square root of 1 plus 3, which is 4. Square root of 4 is 2. I have another point, 1, 2. Now I have 3 points here. 3 points is kind of enough to give you a curve. 2 points gives you a line. You need at least 3 to get a curve going. I'm going to find a few more because I can. So after 4, the next number I could kind of shoot for is 9. What number would go in here to give me 9? X plus 3. I want that to be 9. X is going to have to be 6. 6 plus 3 is the square root of 9. Square root of 9 is 3. I'm going to call it here. To get 16, 13, I don't have enough graph for that. So we're going to stop at 6, 3. 1, 2, 3, 4, 5, 6. Up 3. And if you look, here's my graph. Nice little curve. And if you compare these two graphs, they're very similar. But this one is kind of shifted to the left. This is going to play into those shortcuts that we're going to talk about later. I'll post in the beginning about when those shortcuts are if you want to just skip to the shortcuts. But this graph is just horizontally shifted to the left. It's this graph, just 3 to the left. And that 3 plays a role in that. Domain range. Domain is asking you what's going on with your x values. X is your left, right. You can look at your graph, go, all right, my graph starts right here. Right here is the start of my graph. That is at -3, and it just goes to the right, which means it's getting bigger. So my x is getting bigger, so greater than or equal to, and it starts at -3. You can get that exact same information from the table. If you looked at your table, it started at -3. Remember, this is your start point. Getting this number is important. That's your starting point. -3, and then it just gets bigger. -2. 1, 6. The numbers keep growing because they keep going to the right forever and ever and ever. Your range is your y values. What the hell is going on with y? Well, your y's are up, down. This is going up. You can literally see it trickling up. If you look at your graph, if you look at your table, 0, 1, 2, 3. They're growing. The numbers are getting bigger, greater than or equal to. Then you go, what the hell's happening? What did it start at? Well, it started here at 0. It started at 0. Okay? That starting point is very important on both graphs. Remember, you have to get that square root of 0. This is the most important point. It's why it's the only one that has an asterisk on it. You have to get that square root of 0. Now we're looking at this graph. Now this one, if you notice, is different than both of these. Here, that +3 was inside the radical. This -8 is outside of it. So it's going to be a little different. We're going to see what's going to happen. Once again, if you can't predict what happens, you can still get everything just by plugging in numbers. A table is always going to work. It's always kind of your backup plan, because we're going to teach you shortcuts. Just like you learn shortcuts for slope-intercept, you'll learn shortcuts for parabolas. But there's going to be shortcuts for this. But if you don't understand the shortcuts, plug in numbers, get a curve, it'll work out. Just like here. 0 didn't work out, that's whatever. You plug in numbers and just see what happens. So for this one, square root, this is all that matters. That square root is what I'm gunning for. That -8 I kind of ignore for now. I need square roots. There's only a few perfect squares. Here they are. Obviously they keep going forever and ever, but there's up to 17. Square root of 0. That's easy. Square root of blank would, to be square root of 0, it's got to be 0. X has to be 0. When you plug that in though now, it's the square root of 0 -8. The square root of 0 is 0. So 0 minus 8 gives you a -8. That is slightly different. Then we keep going. What's the next square root I want? I want 1. I want the square root of 1. What number's got to go in here to get me square root of 1? 1. That now gives me square root of 1 minus 8. Square root of 1 is 1. 1 minus 8 is -7. Like I said, this is where you have to think a little bit. I can't just plug in, even though you see 0, 1, you got to fight that urge to plug in a 2 here, because I don't know the square root of 2. If I plug in the square root of 2, I'm stuck. I get a crazy decimal on the calculator, and it's tough to graph. I go here. I did square root of 0. I did square root of 1. I want that square root of 4, so I'm going to plug in a 4 now. And when I plug in a 4, I will now have the square root of 4 minus 8. Remember, this is not 4 minus 8. It's the square root of 4 minus 8. So that's 2 minus 8, and you get yourself a -6. Like I said, this is where you have to think ahead. I got square root of 4. The next number you should be going for is square root of 9. Like I said, I don't want to do a 5. I don't want a 6, 7, 8. All those numbers would screw me up with some ridiculous decimals. I'm gunning for that 9. I plug in 9. Square root of 9 minus 8. Remember, this is not 9 minus 8. It's the square root of 9 minus 8. The square root of 9 is 3. 3 minus 8 would give you a -5. There's my table. I graph this, 0, -8. I'm going to go all the way down. 0, 1, 2, 3, 4, 5, 6, 7, 8. 1, -7, 1, -7. 4, -6, 1, 2, 3, 4. -6. And then this 9, -5. 1, 2, 3, 4, 5, 6, 7, 8, 9, and -5. This is my graph. It goes up, 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 and it's just going to go to the right forever and ever and ever. Once again, if you look at this graph, all three of these graphs look very similar. They just kind of moved a little bit. That +3 moved this graph to the left. This -8 moved the graph down 8. All of these are part of the shortcuts you will learn soon. But once again, if you can't remember shortcuts ever, if you don't remember them, and that's hard sometimes, you're going to learn a lot of shortcuts in math. You're not going to remember them all. Your backup plan is just make a table. Pick numbers, see what happens. Now to domain and range. Domain is your x values. What's going on with my x's? You can look at your graph. My x's, 0, 1, 4, 9. Well, my x's seem to be getting bigger, greater than or equal to. And they seem to start at 0. Now that's me looking at the table. If I looked at my graph, same damn thing. Starts here, x is 0, and it just keeps going to the right, getting bigger. Your range, that's your y values, you're up, down. If I look at my table, it seems to start at 8. And then -7, -6, -5, they're getting bigger, so my y's are getting bigger, greater than or equal to -8. I made a balloon crab. That's him. Even though he's smiling, he's quite crabby. All right, back to this one. So for this one, if you notice, it's very similar to this one. If I move that negative out, it's the same damn problem. But there's a negative in front, and now I want to show you what that negative is going to do. Because once again, all this is kind of trying to lead you to knowing the shortcuts without having to teach you the shortcuts, which you're going to get taught anyway, but little by little, you should kind of be figuring out how all these numbers are affecting the graph. Same game plan. I need square roots I know. Here are the square roots I know. Square root of 0. All right. What number's got to go in here to get 0? -3. At this point, hopefully you're kind of seeing the connection a little more. And when I plug in -3, it becomes negative square root of 0, which is 0. -0, it's 0. There's no positive, negative. It's a neutral number. So you get -3, 0. Now, once again, I need square root of 1. What number goes in there? I'm going to plug in a -2. That becomes negative square root of -2 plus 3 is 1. Square root of 1 is 1, so that becomes -1. The next number I want is 4. What number goes in here to give me 4? Like I said, you kind of ignore that negative. 1 plus 3 is 4, so I'm going to plug in a 1. 1 plus 3 would give me the square root of 4. There's a negative in front, which makes it square root of 4 is 2, so -2. And this is the game you kind of play with these. You're kind of just trying to figure out what number will lead you to these perfect squares. The next perfect square I want is 9. What number goes in here giving me 9? 6. I know that. I literally just did it here. It's the same damn thing, except there's a negative in front. I throw in a 6. That gives me a negative radical 9. And once again, the square root of 9 is 3. There's a negative in front, so it becomes -3. I can't fit any more in here, but you should kind of realize if I wanted to keep going, to get 16, I could plug in a 13 here. If I wanted 25, I would plug in a 22. If I wanted 36, 33. If I wanted 49, a 46. If I wanted 144, I know I could plug in 141 in here. You should start realizing how to make these happen. It's not really anything crazy. They're very basic equations. Now let's graph this and see what it looks like. There's -3, 0. -2, -1. 1, -2. 6, -3. 1, 2, 3, 4, 5, 6, -3. And this graph is going to look like that. Now notice this one's a little different. It almost looks like this, except on the other side. It's reflected a little bit over the x-axis. Not a little bit, it's literally reflected over the x-axis. And you should almost realize instantly why. These are almost identical, except this one has a negative, this one does not. The negative made this go down, and once again, this is all going to eventually lead to us knowing what the shortcuts are. Domain, same game. What's going on with my x's? If you look at your x's on the graph, starts here, goes to the right forever and ever and ever, so your x's are getting bigger. Remember, to the right are bigger numbers. And that leads us to start at -3. Your range is your y values. Now this is where you have to kind of pay attention. For your range, if you look, your y values, it's over here, it's actually going down. When people look at this graph, they don't think of it going down, they just see it going right. But it is going down. You can see it kind of dropping lower and lower every time. It's not just to the right, it's right and down. So your y's are getting smaller, so it's now less than or equal to, and what did it start at? Well, it started at 0. And once again, if you go to your table, you can see that 0, -1, -2, -3, the numbers are getting smaller. That is pretty much, well, there's a lot of other variations to this, but this is kind of all you really need to know for Algebra 1. This is all the kind of mix of graphs you'd end up with. All right? Hope that helps. Next up, shortcuts. All right, guys, so this is the shortcuts section of the video, and this is where really, if you want to actually understand what's happening, you want to pay attention. To be honest, you can get away with a lot of these things without the shortcuts. It's just going to be a lot more work. If you start understanding why these shortcuts happen and how it works, it'll make a little more sense. But to be honest, like I said, you can kind of get away with just plugging in numbers and hoping for the best. For some of you, though, this is going to be your option. So this is the way a square root function generally looks. The previous section, you didn't see all of this because a lot of these were 0. Sometimes you just had an x in the square root because this h was 0. Sometimes you just had an x and nothing here because those were 0. A lot of times you'd have a number in front because that was technically 1, not 0. A lot of options there. This is, if it was full, this is everything that you'd have. So now, what does everything do? So A is what decides whether the graph goes up or down. If it's a positive number, it's going to go up. If it's a negative number, it's going to go down. A is also kind of like the slope. It's not called the slope. But it's slope-ish. It's kind of like the slope. It's going to basically decide how steep the function is. So the bigger the number, kind of the steeper it would be. If you kind of imagine like slope, the bigger the number, it was a much steeper slope. Think of it as skiing, like a ski slope. The bigger the number, the kind of steeper it would be, a little scarier it would be. The smaller the number, it's a little more shallow. So this is like a big number. This would be like a small number. If I'm being honest, you don't really have to know this in Algebra 1, but I want to kind of just give you the full rundown. You do have to know this crap, though. The positive goes up and negative goes down. This is in Algebra 1, they don't really talk about all that much in my experience. If you get to Algebra 2, yeah, you're going to have to know this stuff. But in general, the bigger the number, the steeper. The smaller the number, the more shallow a curve. Very similar to slope. Literally the same thing as slope, kind of. But not slope. Kind of slope. It's slope-esque. HK. These are a little different now. H is what we call your horizontal shift. Now, I like to think people know what horizontal is. I'm not naive about my students. I know as freshmen, most of you know what it is. Some of you may not. Some of you may have just learned this language recently. Horizontal is not a word that you just know off the top of your head. You know it might be up, down, left, right. Sometimes, I know when you're younger, they tell you, think about the horizon. If you don't know what the hell that word means, it's worthless to you. So this is kind of your left-right move. Horizontal is that left-right. Like, so when you think of a horizon, it's left-right. It's flat. Left to right. Now, that minus sign screws things up quite a bit. If you look at the previous problem we did, the second one, it's the opposite of what you think. Because of that minus sign, it's the opposite. So when you see like a -3, it's actually going to be to the right 3. So I want to just make sure you're aware of opposite of what you think. I said that minus h means opposite. It doesn't mean negative. It basically means the opposite of whatever number you see there. So if you see a plus 3, and you're like, oh, plus 3, right 3. It's the opposite. It's actually left 3. If you see a minus 7, in your head you might be thinking, oh, that means left 7. No, it means right 7. Now, k is free. K is on the outside of this radical. Weird things happen in that radical. K, not so bad. For k, what we have is our vertical shift. Now, to be honest, when I was your age, I did use that whole horizon trick to remember this stuff. So basically, I remembered horizon, and then vertical was just the other one. So I knew this was left-right, which makes this your up-down. This is your vertical shift. So basically, if you look at this, that plus 3, that means your graph is going to be starting up 3. If you see this as minus 7, that means your graph is starting 7 down. So once again, let's talk about this. Your original graphs, nothing fancy. This was the first one we did, square root of x. Your square root of x just looks like this. Nothing special, nothing great about it. If you had square root of x plus 3 now square root of x plus 3 is going to tell me that actually this graph, that plus 3, it's a horizontal shift opposite of what I'm thinking. So when I see plus 3, horizontal shift is left-right. When I see plus 3, I'm thinking, oh, that's right 3. It's the opposite of what I think. So it actually would be left 3, and it would look like this. Same game. Square root of x plus 5. Notice that plus 5 is on the outside. I think about this, plus 5 on the outside, that's my vertical shift. So that means I'm going to be going up 5. So 1, 2, 3, 4, 5. It's going to be this graph just up 5. And that's kind of the game. You're just moving this graph. Left, right, up, down. Sometimes you flip it. That A, when that A is negative, once again, something like this, negative x plus 2. When I think about this graph, there's a lot going on here. There's a negative, there's that plus 2. What's going to happen? Well, that plus 2 is a horizontal shift, so that means I'm going to go left 2, 1, 2. That negative lets me know it's going to go down, so it's going to look like this. That's the kind of hints you want. You want to be able to kind of look at these things and just know what's going to happen without doing the work. We're going to do a few more real quick here. So let's actually throw a y in there. Let's start making this look legit. So I'm going to give you a big messy one, something like this. Negative 3 square root of x plus 2 minus 4. This has everything going on for it. It has an a, an h, and a k. This is where, if you understand the shortcuts, I can look at this and know exactly what this graph is going to look like without doing any work. So things I know. My starting point, positive 2, horizontal shift. I see a plus 2, that means left 2, 1, 2. Negative 4 is a vertical shift. That's my up, down. That means down 4, 1, 2, 3, 4. That's my starting point. Negative 2, negative 4, because that tells me left 2. This tells me down 4. Now this negative 3 tells me it's going to go down. And that 3, even though, like I said, you technically don't need to know this crap right now in Algebra 1, but that negative 3 lets you know it's going to be this real, like, kind of fat curve, this real steep slope that's, like, going to be terrifying to actually ski down if it was a ski slope. So it's going to kind of look something like this. A little fatter than usual. Not this, like, skinny one that you have here and here. It's going to be real steep. And that's it. That's kind of what you want to use this for. And like I said, from here, I can pretty much figure out my domain and range without any work. My domain, x, my x starts right here at negative 2. It's going to the right. It's getting bigger, greater than or equal to. My range, it's my y values. Up, down. It's definitely going down, so less than or equal to. What did it start at? It started right here at negative 4. We are going to do one more, just kind of show you how this works. Once again, Let's make an f of x equals negative, let's say 1/3 radical x minus 5 plus 2, something like this. You don't need to do much. Like I said, this is really just to kind of get an idea what's going on with the graph without doing any work. I'm showing you the graph, but the goal is that you just look at this and envision what it's going to look like. So I see this -5. In my head right away, I'm like, all right, this -5 is telling me, I see a -5. I think left 5. It's the opposite of what I think, so it actually means right 5. So from 0, I'm going to go 1, 2, 3, 4, 5. This +2, that's my vertical shift. That's my up-down. That tells me it's up 2. So I'm going to go up 1, 2. That's my starting point. Right off the bat, I know where I start. I didn't do any work, just looking at this. The negative tells me it's going to go down. Now that 1/3 actually does tell me, and like I said, this is that little more advanced thing. You don't really need this for Algebra 1. It's great to know, but honestly, in Algebra 1, you don't really do a lot of this. This lets me know it's going to be a very shallow slope. It's not going to be steep. It's going to be a very... If you were to be a skier, it'd be very boring to ski down. It's going to be very blah. It's going to look something like this. Like bleh. Not really a straight line. Definitely a curve. But not something like this. Not something like almost fun to go down. This is kind of normal. This is very shallow. It's almost straight, but it's not. It's a very shallow curve. And those are the shortcuts. And like I said, with this, my domain and my range, I can get my domain and range without any work. I don't even need the graph. I can look at this and figure out my domain and range. My x's. Yeah, starts at 5. And I know it goes to the right greater than or equal to. My range, my y values, starts at 2. This lets me know it's going down, though, so less than or equal to. Now, to be honest, in my head, I do visualize this before I write my domain and range. I picture this, and then I write that. I have a feeling most of you are going to have to kind of be similar. Some of you might even need to draw it sometimes. I think drawing it does help. That's why I drew every single one of these. But at some point, I think a lot of you are clever enough to not have to draw this stuff. So, you know, pick your poison. It doesn't take a lot of time to kind of just draw a little curve. And that's it, guys. Hope that helps. Mercado out.